Alright, this is 6.2 homework help. First problem gives us some length to the sides of this triangle over here, and it wants the cosine of theta. Theta is right here, so the cosine of that, we have to remember our relationships for these trig functions. Cosine is adjacent over hypotenuse, so it'd be 5 over 13. So you might want to remember SOHCAHTOA, at least. And then, obviously, then sine of that same angle would be opposite over hypotenuse, so it'd be 12 over 13. Tangent of theta is opposite over adjacent, so that'd be 12 over 5. And then the cosine of phi up here, now we're looking at this angle, so it'd be adjacent over hypotenuse, which is 12 over 13. And the sine of phi would be opposite over hypotenuse, that'd be 5 over 13. And then we want the tangent of phi, which is opposite over adjacent, so that's 5 over 12. Alright, the next problem tells us that angle A is pi over 4. If angle A is pi over 4, then so is this angle up here. It's an isosceles right triangle. That's a 45-degree angle. So we can do, this has got to be isosceles, so that's 5, B is 5, and C is then the small leg times the square root of 2. So we have 5 and 5 square root of 2. Obviously, you could use cosine and sine as well if you wanted to use this angle, but special right triangles are probably the easiest if you remember your relationships, that x, and x squared root of 2 is your relationship for a 45, 45, 90 right triangle. Okay, the next problem wants us to find these trig values here. If you do the Pythagorean theorem, you're going to find that this is 9. If you do 41 squared minus 40 squared square rooted. Now, I can find sine of the angle x is opposite over hypotenuse, so that's 40 over 41. The cosine of x is adjacent over hypotenuse. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Secant is reciprocal of cosine, so that's 41 over 9. And cosecant is the reciprocal of sine, so that's 41 over 40. Now, an easy way to remember this, as far as what is what, if you write cosine, sine, and tangent, keep in mind that there's always a co. So cotangent obviously goes with tangent. Tangent would be cosecant, so that there's a co there, and then secant goes with cosine, so they're reciprocals of one another. So there's always a co in each pair. There's a co in each pair. That's a good way to remember it, to keep these two straight. And obviously tangent goes with cotangent, but just remember each pair has a co in it, and you should be good. The next problem, if we're going to find x, what we would do is we'd do the cosine of angle z equals adjacent over hypotenuse, and then we'd multiply both sides by 28 to get x. So that'd be 28 cosine of z. Next one, if we're going to find y, we'd do sine of angle z equals opposite over hypotenuse. We'd multiply both sides by 28, and we'd get y is 28 sine of z. Okay, the next problem gives us two components of speed. So we're descending in an airplane towards the ground. Now what they give us here is two components of our velocity. They give us this component here, where I'm headed towards the ground and sinking at 290 feet per minute. And they also give us this component here, the ground speed, which is 74 miles per hour. And then they ask, you're going to hit the runway at an angle of, so we're looking for the angle we're going to hit the runway. So we're going to try to find this angle. Now, the units are going to be an issue. We need to make sure they're both in the same units. We have feet per minute and miles per hour. So I guess I'll just convert this one to feet per minute. So I know that there's 5,280 feet in 1 mile. That way the miles cancel. And I'll be in feet. Now I need to get rid of the hours and get that into minutes. So 1 hour is equivalent to 60 minutes. That way the hours cancel. That gives me 6,512 feet per minute. So I'm using this 6,512 and the 290 to find the hypotenuse using the Pythagorean theorem. I'm sorry, actually you need to do inverse tangent. So if you do tangent of theta equals opposite over adjacent, and then do inverse tangent. Inverse tangent of 290 over 6,512 gives you the right angle, which in this case is 2.5499 about, if I'm pretty accurate here. Okay, the next problem says consider a right triangle whose short sides have length 5 and 12, and they want the smallest angle. Now, if you remember from geometry, the smallest angle is across from the smallest side, so we need to do tangent of theta equals opposite over adjacent, and then we can do inverse tangent of 5 over 12 to get our answer, which ends up being about 22.62 degrees. Okay, the next problem gives us some information here, which we're going to graph. It tells us that we have an acute angle, and it tells us that angle has a cotangent of 1, which means that adjacent over opposite is 1. So I'm just going to make both of these 1s. That way when I do adjacent over opposite, I get 1. If I do the Pythagorean theorem, the hypotenuse then would be the square root of 2. So then I can find the sine is opposite over adjacent, so that's 1 over the square root of 2. I could rationalize the denominator. We're just going to leave it like this. Cosine would then be adjacent over hypotenuse, tangents opposite over adjacent, secant's the reciprocal of cosine, so it's just the square root of 2, and cosecant's the reciprocal of sine, so that's just the square root of 2 as well. Okay, the next problem wants to find the exact value without using a calculator. So the first one is tangent of pi over 3. Pi over 3 is 60 degrees. That's right on your unit circle. This gives you 1/2 for cosine, and sine is square root of 3 over 2. So I can do tangent as opposite over adjacent, so I can do sine over cosine. And to multiply by the reciprocal, instead of dividing by 1/2, multiply by 2 over 1, and you just get square root of 3. So that's what we're going to do for all these. So you have to just find these angles. The tangent of 11 pi over 6 is, if you divide 6 into 11, it goes in 1 time, you follow through, and you get a remainder of 5. So it's 1 and 5, 6. So what that means, you go around 1 pi, and you go around another 5, 6 pi, which leaves you 1/6 pi short of 2 pi. So you're over here. That's right on your unit circle, you might remember, in which case if I want tangent, I want opposite over adjacent. This is negative 1/2 for the side. In fact, I'll just write the order of pair. This is square root of 3 over 2, comma, negative 1/2 on your unit circle. So tangent would be opposite over adjacent, so it would be negative 1/2 over square root of 3 over 2. So I'm going to multiply by the reciprocal, which would be 2 over the square root of 3. 2's cancel, and I get negative 1 divided by the square root of 3. I'll let you guys finish these then, but you want to find the angle first and then do the relationship once you know what point you're at. Same thing with this one. If you're looking for the tangent of negative 60, first look at that on the unit circle. This is an order pair is 1/2 comma negative square root of 3 over 2. So the tangent of that angle, if I rotate down negative 60, will be opposite over adjacent or sine over cosine. So it's negative square root of 3 over 2 divided by 1/2. Instead of multiplying by 1/2, or divide by 1/2, let's multiply by 2 over 1. So you get negative square root of 3. Same thing with cotangent of the same angle. Cotangent is the reciprocal of tangent. So all I'm going to do is do the opposite. We'll do adjacent over hypotenuse or cosine over sine, which I can just reciprocate this negative square root of 3 as well and make it 1 over negative square root of 3. Alright, same thing for the next problem then. It gives you angle 7 pi over 6, which we know is down here. It's pi over 6 more, or 30 degrees more. We'll use pi over 6. More than pi. And that's right on a unit circle. It tells us that this is negative square root of 3 over 2, comma, negative 1/2, which we already know from our unit circle. And so the angle we're looking for in degrees would be 180 plus 30, which is 210. And then we can find the cosine is just the x-coordinate, so that'd be negative square root of 3 over 2. Sine is the y-coordinate, that'd be negative 1/2. And tangent is sine over cosine, so that's negative square root of 3 over 2 divided by negative 1/2, which the double negatives cancel, and I can multiply by the reciprocal, 2 over 1, to get the square root of 3.